Hello, it's me again. We're going to talk about mass for this one. So lesson 2, mass. So this first section answers numbers 1 and 2. So for number 1, which is larger, between 1 pound or 100 grams, 1 pound is going to be larger. It is equal to about 453.6 grams. For number 2, between a kilogram and a pound, a kilogram is larger. 100 kilograms are equal to about 220 pounds. And for the third part, 1 ounce or 1,000 milligrams, 1 ounce is larger. So 1 ounce of gold, for example, would be equal to 28,349.5 milligrams. And by the way, these three will answer your number 2, whereas this part is number 1. So this part goes through numbers 3 through 7. And so for number 3, mass refers to the amount of matter in an object. So it's talking about how many atoms or molecules you might have in an object. For number 4, the base unit of mass in the metric system is the kilogram, and you represent that with kg. So if you say you have 5 kg, you have 5 kilograms of something in mass. For number 5, the standard for a kilogram is equal to the mass of what they call the International Prototype Kilogram. So you might want to pause that for a second so you can write that down. But what that is there's a picture of it over here, and it is a platinum iridium cylinder kept by the EIPM at Sevres, France. I might have said that wrong, but basically it is a standard that we use as a kilogram. That thing is a model for what 1 kilogram should weigh. Okay, and so for number 6, more metric units, 1 kilogram is equal to about 1,000 grams, and 1 gram is equal to about 1,000 milligrams. So you're probably seeing a pattern here from the length one already, because anything that's milli goes 1,000 into whatever the base unit is, right, which is meters, grams, or liters, and then there are 1,000 of that base unit in whatever your kilo is. That's how you kind of convert stuff. It's really easy in metric. That's why science uses metric. And then for number 7, which is larger, with part A between 1 kilogram or 1,500 grams, it is going to be the grams, because since there are 1,000, we have about 1.5 kilograms there. For part B, 1,200 milligrams or 1 gram, it's going to be the 1,200 again, because that equals about 1.2 grams, right? And that's larger. For part C, between 12 milligrams or 12 kilograms, it's going to be the 12 kilograms for sure, because the kilograms are huge, right? And then for part D, between 4 kilograms or 4,500 grams, even though kilograms are large, this is still a lot more. Since there are 1,000 grams in a kilogram, you get about 4.5. Because you would move the decimal over 3 places.
1,000 grams? This package of ground beef is 1 kilogram. Remember, there are exactly 1,000 grams in 1 kilogram.
This 5-kilogram roast can easily serve over 10 or 12 people.
Whereas a 10-kilogram turkey should serve about 20 happy appetites.
Kilograms can be very heavy. 40 kilograms requires a strong back to carry. But 1,000 kilograms is 1 ton. At home, around the world, kilogram is the base unit for mass.
This part will answer numbers 8 and 9. So for number 8, it asks, what instrument will we use to find the mass of objects? That will be the triple beam balance, which you guys have seen or will see in your lab here. We use that to find the mass of various objects. It says the objects are placed on the scale, and then you move the weights on the beams until you get the lines on the right side of the scale to match up. Those little silver lines, you guys want them to match up, because if they don't, you do not have it weighed properly. Once you've balanced the scale, you're going to add up the amounts in each of your weights. This one is the tens place, this is the hundreds place, this is the ones place. So this particular one will be 373.4, it looks like. So 373.4 to find your total mass. So there it is, the total mass of the object measured in the picture, 300 for the hundreds place, 70 for the tens place, and we'll put 3.4 for the ones place, and then when you add those up, that's your mass, 373.4. This last section covers number 10, and I'm going to kind of just read it off to you and underline the key parts. So, to measure mass using the triple beam balance, first you place the film canister on the scale. Next, you slide the large weight to the right, so that biggest one, the hundreds place, and do it until the arm drops below the line, and then when it drops below, so when this thing goes lower, once it does that, you move it back to the last one so that it moves back up. And then for the third one, you repeat the same process, but with the top weight. That's going to be your tens place weight. And then you're going to move that till it goes below the line, then move it back up. And then you're probably seeing a pattern here. Fourth, you're going to slide the small weight now, and you're going to do that on the front until those lines here on that part match up. And then fifth, add the amounts on each beam to find the total mass to the nearest tenth of a gram.